Bienvenidos al Vermú de Nanociencia, la actividad del festival 10 a la menos 9 que te acompañará durante 6 semanas para acercarte un poco más al mundo nano. El vídeo de hoy se enmarca dentro de la sexta semana del Vermú dedicada a la nanomedicina. Yoliswa Bhembe, quien trabaja en consultoría navío en Sudáfrica, nos hablará de nanopartículas teragnósticas en su charla titulada Theracnostic Gold Nanoparticles for the Treatment of Glioma. Escucha la charla, dinos qué te parece y comparte tus dudas en los comentarios. Lo resolveremos este viernes 2 de junio a las 12 del mediodía en la mesa redonda del Vermú con Yoliswa y el resto de ponentes de esta semana. Y si quieres resolver tus dudas en directo, solo tienes que unirte al link de Zoom que compartiremos en nuestras redes. ¿Quieres un Vermú? Tómatelo con nanociencia.
Good day, everyone. My name is Yoliswa Bhembe, and I'm an ambassador at a consulting company called Código in South Africa. And today I'll be presenting to you a talk or a lecture titled Theracnostic Gold Nanoparticles for the Treatment of Glioma. So in introduction, we start with the central nervous system, which is shown by the picture on our far right. It shows the spinal cord as well as the brain. So these are the core two parts that makes up the central nervous system, and they're housed within a protective layer, which layered membrane, which is called the meninges. So this central nervous system serves as the body's command or processing center. It has the gray and the white matter, and these matters are shown by the picture on our far left, on our far right. So in the gray matter, it is where the processing is done, and in the white matter, it is where the channels of communication are actually at or controlled. So in these matters, there are cells that are found in it, not limited to, however, to these glial cells. So the glial cells that are found in these matters can also be called glial or neuroglial, which provide structural support and are categorized as the astrocytes, oligodendrocytes, epithelial, and as well as epidermal cells. So any accumulation of genetic mutation that can occur in this glial cell can actually result to the formation of a brain tumor. That is refers to a glioma. So let's look into what is this glioma. So a glioma is a type of a tumor that occurs in the brain and spinal cord stemming from the glial cells, which is where the genetic mutation occurs, the glial cells. So the gliomas are the most common types of tumors that occurs at the central nervous system, accounting to 27% of all brain tumors and as well as 80% of all the malignant tumors, right? So there are current methods that are used for the diagnostic and as well as treatment. And then they actually include the surgical session of the tumor, which entails radiation therapy, followed by the adjuvant chemotherapy with temozolomide. However, this method fails since complete glioma recession is hindered. The factors that hinders complete glioma recession includes the irregular and indistinct tumor margins, as well as the infiltrative nature of high-grade gliomas invading essential neurological structures. Also, the oncotherapeutic and diagnostic agents fail to achieve sufficient concentrations at the tumor vicinity. And certain intervention strategies are actually there. However, they are highly invasive and they cannot be used over a long-term treatment. And there's also poor solubility and short half-lives of many therapeutic agencies in the blood circulation, which further limit the chemotherapy efficiency. Thank you to nanotechnology, however, which has come with nanomedicine. And it has, this nanomedicine has emerged as a promising alternative that can surmount all these hurdles of the conventional imaging as well as treatment of glioma. So in nanomedicine, there's a use of nanoparticles or nanomaterials. In this case, we'll be focusing on gold nanoparticles. Gold nanoparticles have been used in nanomedicine because they've attracted so much attention due to the virtue of their properties. So looking now into gold nanoparticles, which are just particles that are within the diameter or the range of 1 to 10 nanometers. And when dispersed in water, they're just called colloidal gold. These nanoparticles have been used in nanomedicine due to certain properties that include their synthetic versatility, which yields to various morphologies. And this means that these nanoparticles can be synthesized or can be manufactured to exhibit different structures and then or shapes, which are shown by the picture on our far right. They can be nanospheres, nanocubes, nanoflowers, nanorods, depending on how they are synthesized or manufactured. And these different types of morphologies or shapes come with certain properties that are crucial towards the treatment and as well as diagnosis of the glioma or the cell or the cancer cells. And also these gold nanoparticles have a tunable surface functionality, which directly conjugate and interact with diverse molecules. This means that these nanoparticles, these gold nanoparticles, have a function that allows them to be conjugated to other molecules. And this is shown by the picture on our far right. These molecules are going to be conjugated include drugs, protein, RNA or DNA, enzymes, and as well as antibodies, among others. And these nanoparticles are quite stable. They are chemically and physically stable. So their stability allows or favors their use. And also, they have a unique engineerability optical properties. This means that their light properties allows or favors the use of these gold nanoparticles towards imaging that is during diagnostics, right? So we move further into summarizing what we just spoke of. This picture here shows the summary of the properties and as well as how they maneuver towards the treatment of the glioma. The psychochemical properties, which include the size, shape, surface charge, and functionality. Now, remember we said they range within 1 to 100 nanometer. So the size comes in handy when you want to channel your gold nanoparticles to be able to pass through the blood-brain barrier towards tackling those cells. So now you can control the size because the size is controllable. You can control the size to suit the one that is suitable towards tackling those cancer cells, as well as the shape. You can also tune or control it to suit the one that will be able to pass through the blood barrier, as well as the surface charge, which can be positive, negative, and neutral. You can also synthesize your materials to exhibit either of these surface charges. And the functionality, now the ability of these gold nanoparticles to conjugate with other molecules, which could be your gene, your protein, your peptide, or your RNA or DNA. So now that again further comes with properties that allows the direct tackling or treatment of the glioma cells. So which is what is shown in this slide. Now moving on into the theranostic application of gold nanoparticles. On our left, we are having this image which shows the gold nanoparticles in general that can be used toward diagnostics, which is the biological and chemical sensing part. We said the tunability of the lighting properties or the optical properties comes in handy towards the diagnostic part. There's also delivery, which now the functionality of the materials of the gold nanoparticles now being the functionality is in the ability to attach to other molecules, which could be your gene, your protein, or your drug. Now that can be used towards drug delivery, as well as therapy. Again, therapy, the lighting properties comes in handy, as well as in imaging, where they can be used towards in X-rays and CT scan. And then now on the right, it further summarizes what is on the left. In drug delivery, photodynamic therapy, photothermal therapy, sonodynamic therapy, as well as radiotherapy. All these properties are the properties that shows all these properties are the properties that shows how the use of gold nanoparticles comes in towards the treatment of these glioma cells. And then here we have just two examples which show the direct treatment of glioma by the gold nanoparticles. In picture A, it's actually treatment of glioma cells of glioma, which is the brain tumor, by apoptosis, which is during that the gold nanoparticles effectively inhibit the proliferation of cells due to apoptosis. And the gold nanoparticles here effectively induce apoptosis via ROS-mediated mitochondria. And then in B, it's endocytosis. The gold nanoparticles here are adsorbed on the surface of the PGM via chelation, which results to the treatment of glioma via endocytosis. And then in conclusion, we can say that we have seen how gold nanoparticles have generally exhibited significant improvements in diagnosis and as well as the therapy of malignant gliomas. And also, in overall, these gold nanoparticles have shown that they can provide more accurate and more enduring preoperative and intraoperative multimodal imaging, which enable complete recession of migrated tumor cells. And further, the gold nanoparticles can assist in to deliver a variety of therapeutic efficiency, which overcome the blood-brain barrier. And also, the amalgamate various therapeutics modalities in one platform, rendering their synergetic effects, which comes with the gold nanoparticles. And also, the gold nanoparticles can accordingly enhance the efficacy of the current therapeutic modalities, which can really help towards tackling the problem of this brain tumor. And then we have our references here, a few of our references that we used to bring together this talk. I thank you all. Thank you.